Hello and welcome to our 6th video on Pythagoras and Trigonometry. I'm Mr. Chowdhury and today we're going to be looking at using trigonometry to find missing angles. Now if you haven't already, I suggest you go and watch our videos on using Pythagoras to find missing sides and using trigonometry to find missing sides, and more importantly watching our video on which ratio to use. They are the videos you have to watch before you come and watch this one. But if you've watched those and you're feeling pretty confident with that, then we can move on with this topic. So here's what we're going to do. We have got a right angle triangle here. We have a right angle triangle here and we have an angle. The first task for you to do is to label this triangle. So pause the video and label this triangle with regards to that angle. So hopefully you've had a chance at having a go at labeling it. I'm going to help you label it now. So here's my right angle and I know my hypotenuse is always directly opposite my right angle. So we're directly opposite and that's my hypotenuse. Here is my angle, and I know my opposite is opposite the angle. So I go directly opposite and I label that one opposite. And the one that's left over is my adjacent. It's just next to the angle. The word adjacent means next to, so it's just next to the angle. Now we've already looked at what the ratios represent. We already know what sine, cosine and tangent represent with regards to the triangle. What ratios are they? Which sides do they work with? So we're going to use that information to try and work out what the values of sine theta is. So what's the value of sine theta within this triangle? Pause the video, have a think. Now, let's have a look. We know that sine theta is the opposite divided by the hypotenuse. So the value of sine theta in this triangle is 4/5. So the ratio of sine theta will give us the ratio 4/5. That's what this triangle tells us. What about cos theta? What ratio will cos theta give us? Okay, so if we look, cos theta is the adjacent over the hypotenuse, the adjacent divided by the hypotenuse. So my adjacent is 3, my hypotenuse is 5, so I get 3/5. So I just get this fraction. So far I've got 4/5, that's one of the fractions. I've got 3/5, that's the second fraction. Okay, and our last one, tan theta. What would that look like? What fraction would that give us? What ratio would it give us? What's the value of that ratio? Okay, let's have a look. Opposite over adjacent, so that's 4/3, which is 4/3, or 1 and 1/3. So hopefully that's been pretty straightforward for you to do. All you have to do is really label a triangle and then find some values. Here's 2 questions for you to try. All I would like you to do is first label the triangle. So pause the video and label the triangles, please. Okay, so you've done that and I'll help you label them. So there's my hypotenuse on this right hand triangle, opposite adjacent, hypotenuse, opposite adjacent. Right, once you've done that, tell me what the values of sine, cosine and tangent are for these 2 respective triangles. Pause the video, have a go. All I'm looking for is that fraction. What is that fraction that sine theta would give us for this left hand triangle? What is the fraction that cos theta would give us for the right hand triangle? I'd like you to do that for both, please. Pause the video and have a go at that. Okay, so let's have a look at these answers. So for the left hand triangle, sine theta would be 5/13, cos theta would be 12/13, tan theta would be 5/12. So that's for this left hand triangle. As you can see, all I've done is written the opposite divided by the hypotenuse as a fraction. I don't need to convert it to decimals, we can just leave it as a fraction. For the right hand triangle, this is what I've got. I've got 15/17 for sine theta, 8/17 for cos theta, and 15/8 for tan theta. So hopefully you've got those right and you're feeling very comfortable about just writing the fractions that are represented by sine theta, cos theta, and tan theta. That should be pretty straightforward for you now. We're just going to take a slight detour and look at our calculator. So you haven't already, I'm going to give you a sec. Go grab your calculator, pause the video, go grab your calculator and come back. Okay, so initially you might think it's to divide by sine or something like that. Well, that's not actually the case. We don't actually divide by sine. So sine is a ratio. It's applying a ratio to a triangle. That's what sine is. So the inverse of sine is not dividing by sine. The inverse of sine is what we call sine minus 1, cos minus 1, and tan minus 1. And what we do is we do these new functions to theta to get our answer. Now you may be asking me, sir, where is sine minus 1? Where is cos minus 1? Where is tan minus 1 on my calculator? Well, if you have a look at my calculator, there they are, just directly above sine, cos, and tan. Now, you might be asking, how do I access these buttons? How do I get to them? Because there's not actually a physical button. It just says sine minus 1, cos minus 1, tan minus 1. Well, for my calculator, I would press shift, then sine, then I press shift, then cos, and then I press shift, then tan, if that's what I wanted to do. So hopefully you're able to add sine minus 1, cos minus 1, tan minus 1 on your calculator. You may be able to get them to appear. You can access them by pressing shift and then pressing the button. Now we're going to look at something that will help you use these. So this was a little detour to understand where the buttons are on a calculator. Now we're going to go back to what we're actually doing, which is finding missing angles. So here is 3 examples of the same triangle, but we're working with sine, cosine, and tan. What I'd like you to do is pause the video and tell me what we've done in each bit of working. Pause the video and tell me what we've done in each bit of working. Okay, so let's have a look at this cosine question that we've done, and we're going to talk through each step. So the first step is we wrote the ratio down. So we know cos theta is equal to the adjacent divided by the hypotenuse. So we've written that down. The second step is that we've substituted in the values, just like we did earlier on, is we just put in the values for the adjacent, we put in the value for the hypotenuse, and we've got this fraction. That's what the ratio represents. The next thing we've done is apply the inverse. So because we want to know what the value of the answer is, we want to know what the angle is, we have to do the inverse of sine, cosine, or tan. In this case, we're going to do the inverse of cos. So we had cos theta equals this fraction. So I want to go backwards. So I'm going to do cos minus 1 of that fraction, and that will give me the value for theta. And here is the answer, 36.9. As you can see, it's the same for sine, it's the same for tan, because we're working with the same angle in all 3 examples. So here's what I'd like you to do. We've already looked at these 2 triangles. We've already labeled them. So we're just going to label them again very quickly for you. So now we're going to try and work out the value of the angles that we have. So we're going to look at this one on the left. We're going to look at the one on the left. So I know that sine is opposite divided by the hypotenuse. So if I want the angle, I need to do sine minus 1 of the opposite divided by the hypotenuse. And that gives me 22.6. So that's what we think the value of the angle is. And I'm just going to check that with doing the same with cos. So I know cos is the adjacent divided by the hypotenuse. So I'm going to do cos minus 1 of 12 divided by 13. And once again, I get the same answer because I should. It's the same angle I'm working with. And I'll do it one more time for tan. So I get tan minus 1 of 5 over 12, which gives me 22.6. So I've got the same answer for all 3. What I'd like you to do now is pause the video and have a go at the one on the right, and I'll give you the answers in a minute. Okay, so hopefully you've had a chance at doing this. Let's have a look at the answers for this right-hand triangle. So I know that sine minus 1 of 15 over 17. 15 is my opposite, 17 is my hypotenuse, gives me my angle of 61.9. Cos, once again, the adjacent is 8, the hypotenuse is 17. So cos minus 1 of 8/17 gives me 61.9 again. And once again, tan 15 over 8, tan minus 1 of 15 over 8 gives me 61.9. Now, you may be asking yourself, well, sir, we can do this when we have all 3 sides and we know what we're doing. I can do sine minus 1, I can do cos minus 1, I can do the inverses. How do I answer some questions? So let's look at an example before you go and do some practice. So here is your example. You need to work out the value of theta. What I'd like you to do is pause the video and have a go. Doesn't matter if you don't get all the way through it. All I want you to do is have a go at it and see which steps you've held on to. Which steps have you been able to work out without my help? And then I'll come back and we'll go through this example together, and then you can go off and do some practice. So pause the video, have a go at that, please. Okay, so hopefully you've had a chance at having a go at this question. So let's do it together. The first thing we should do is label this triangle. So we're going to label this triangle. So I'll quickly label it for you. Hypotenuse, opposite, adjacent, done. We've labeled the triangle correctly. The next thing we need to do is we need to circle what we have and circle what we want. We're going to circle what we have and circle what we want. So we have the opposite. We have this 12 centimeters. We have the adjacent. We have the 13 centimeters. We want the angle, right? We don't care about the hypotenuse in this situation. We have the opposite. We have the adjacent. We want the angle. So which one of our ratios are we going to use? So I've written SOHCAHTOA there for you. Which one are we going to use? Which one has opposite and adjacent in it? Well, that's TOA, tan, that one there. So then we're going to write down the tan ratio for us. We're going to write down the tan ratio. So that's tan theta is equal to the opposite over the adjacent. Tan theta is equal to the opposite over the adjacent. Then we substitute our values in. So I know that tan theta will give me the fraction of 12 over 13. Tan theta gives me the fraction of 12 over 13. Now, I want the angle. So what I need to do is the inverse of tan. The inverse of tan is tan minus 1. So I do tan minus 1, and then I end up with theta is equal to tan minus 1 of my fraction. Tan minus 1 of the opposite over the adjacent. Tan minus 1 of 12 over 13. Then I just press equals in my calculator, and I get 42.7093, and it carries on. And I just round that to one decimal place, 42.7. Now, hopefully that's been really helpful for you, and you can work through questions to find missing angles. What I suggest you do now is ensure that this working is written down somewhere in a book on some paper, or you can just quickly screen grab the working so you have it with you. Then what I'd like you to do is go watch Mr. Amoson's video to do some practice and try and see if you can apply what we've learned in this video on there. If you're feeling super confident and you think, I don't need to watch Mr. Amoson's video, I think I can do this, then you go and watch some Dr. Frost, you go and do some questions on Corbett Maths, and hopefully that will help you out. Go off, be productive, and I'll see you in the next video.